Dear students, in our previous class, we have discussed a short topic regarding linked lists. Today, I am going to explain you regarding the same thing, linked list, so that you can become completely clear about linked lists. So, as we have discussed many types of, that is the classifications of data structure. Same as here, the linked list is also one of the classifications of data structures. As we have discussed, array is a classification of data structure, stack is a classification of data structure, queues as a classification of data structure, and all these three classifications are having their own operations and memory representations. And the same way here, linked list is also one of the classifications of data structures. So here, why we will use linked list instead of using arrays? Because array is a static structure where insertion of an element in an array or deletion of an element from the array, it will create a problem. In a list of elements, if in an array, if you want to insert any item, okay, this is a stack, it's an array, okay, A, B, D, E, okay, or A, B, D. If you want to insert one more element, that is C, then at that time D will be moved here, then C will be inserted in its place. So the lower memory location elements will be transferred to the higher memory locations. And if you want to delete C from here, then this D from higher to lower it will move. So this creates a problem in an array, because array is a static structure. So instead of using arrays, we will use linked list. Linked list is a dynamic data structure. Okay, come we shall see what actually the linked list means. Linked list. Okay, we can explain this as linked list is a linear collection of data elements called nodes, and each linear collection and the linear order is given by means of pointers. So what is linked list? Linked list is a linear collection of data elements. Okay, it is also a collection of data elements, just like stack is also a collection of data elements, array is a collection of data elements, and also the queues is also a collection of data elements. The same way here, linked list is also a collection of data elements. Those data elements are called as nodes. See, node will be like this type. This is called as a node. Okay, and the linear order is given by means of pointers. The linear order means order of these nodes is given by means of pointers. Here in linked list, okay, every node is having two parts. The first part will be called as the data part, and the next part is called as reference of next node. Reference of next node, This is called as a reference of next node. What this pointer means? Pointer means it is a link or the connection can be called as pointer. This is a start pointer and this also can be called as head point. Head. Okay, start and head both are same. Look here. This is a linked list which is having some number of nodes here. Okay, this is a start pointer. It will connect it to the first node. Then every node is having, see, these are number of nodes. Node 1, node 2, node 3, like n number of nodes up to node n. Any number of nodes you want, you can create. First part is the data part, okay, which contains its own data, the data of that node. Okay, then next the reference field or the link field. Reference of next node or the link field. It contains a pointer, okay, and the address of the next node. It contains a pointer which shows the address of next node, and this node is having its own data, and the next field contains the address of the next node. Then this data field is also contain some data. Then finally the end of the node will be null, because at last no node is there. There is not any node. Okay, there is no node, so for that pointer shows null. Okay, so this is actually the linked list. It is a linear collection of data elements called nodes, and linear order is given by means of pointers. Pointers means address of the next node is called as a pointer here. Okay, basically each node in linked list contains two fields. One is data node, the another one is reference of next node or the link field. Okay, hope you have understood about the linked list. Why we will use linked list instead of arrays? Because arrays is a static structure, so the insertion and deletion of elements creates a problem. Because while inserting an element, the element, the lower location element should be moved to the higher location pointers. If you want to remove any element from the array, then at that time, if an element is deleted from the array, then the higher location elements will be moved to the lower location. So this is a problem. So for overcoming this problem, instead of using arrays, linked lists can be used. Same as the types of stacks, types of arrays, and types of queues. Here we are having the types of linked list. Come, we shall see which are the types of linked list. There are three types of linked lists. The first one is singly linked list. Singly linked list. The next one is circular linked list. Circular linked list. And the last one is doubly linked list. Singly linked list, circular linked list, and doubly linked list. These are the three types of linked list. Now, we are going to discuss each linked list one by one. What is meant singly linked list, and what is circular linked list, and what is doubly linked list. Singly linked list. A singly linked list contains a singly linked list contains two fields in each node, where the first field is, here contains the fields in each node, the data field and the link field. The data field and the link field. Okay, the data field contains its own data, where the link field contains the address of the next node. The address of the next node. The address of the next node. Since singly linked list is having only one link field, so it is called as singly linked list. Singly linked list. Here, dear students, a singly linked list contains two fields in each node. Okay, each node of a singly linked list contains two fields. The first field is the data field, and the next one is the link field. Here, link field can also be called as the reference of the next node. Okay, the data field contains, look here, the data field contains its own data. Okay, it contains some data, which is the data of its own. Okay, then the link field contains the address of the next node. This link field contains the address of next node. And in singly linked list, there is only one link field. So for this purpose, this type of linked list will be called as a singly linked list. This can be same as the definition of linked list, but little bit elaborated. So you have to write like this. A singly linked list contains two fields, the data field and the link field. The data field contains its own data, whereas the link field contains the address of the next node. Since singly linked list is having only one link field, so it is called as singly linked list. You can write a singly linked list diagram like this. Okay, this is start or head. Okay, then write 2 or 3 nodes. If you write 2 or 3 nodes, then this is a pointer connect to first node. It contains some data, and this field of a node contains the address of next node, and this contains some data. This field, link field, contains the address of next node, and this contains some data. And finally, this shows null here. Node 1, node 2, node 3. Data field contains data, link field contains the address of next node. Data field contains its own data, link field contains the address of next node. Like this, the link field is finally null because there is no any node. Hope you have understood the singly linked list. Come now we shall discuss what is meant by the circular linked list. Circular linked list. Okay. What is circular linked list? It is a linked list in which it is a linked list in which the link field of the last node contains the address of the first node See, circular linked list, it is a linked list in which, okay, the link field of the last node contains the address of the first node. Okay, start or head, right, like this. Then 2 to 3 nodes, 1, 2. Okay, any number of nodes you want, you can write. Okay. Having some data, then contains the address of next node. Having some data, then contains the address of next node. Having some data, then here, see, the link field of the last node. This is the last node and this is the link field. Okay, the link field of the last node contains, okay, the address of the first node. Okay, link field of the last node contains the address of the first node. Okay, this type of linked list will be called as a circular linked list. But in singly linked list, there is one drawback. To overcome from that drawback, here circular linked list is used, because singly linked list has contained, okay, singly linked list has contained only the address of the succeeding node. Okay, it contains only the address of succeeding node, upcoming node. Okay, but it will not contain the address of the preceding node. This is the drawback of singly linked list. So overcome by this problem, and finally this leads to null here, because if there is no node, finally it gives null. This is singly linked list. To overcome by this problem, circular linked list will be used, because the last node again contains the address of the first node. So here there is no null pointer. Okay, for this we will use a circular linked list. And one more condition is here. In circular linked list, In circular linked list, any node can be reached from any node. Okay, from here if you want to reach second node you can reach, or from here if you want to reach the first node you can reach. So this type of linked list will be called as a circular linked list. Here one more rule is there. A circular linked list, in circular linked list any node can be reached from any node. Okay, there is no condition that last node must be reached first node, no other nodes can be reached, not like that. It is explained here in the way so that you can understand. And finally it has given you some idea that from any node you can able to reach any node. This is called as circular linked list. Next, come to the doubly linked list. Doubly linked list. We have discussed singly linked list and circular linked list. Now doubly linked list. What is doubly linked list? It is a linked list. It is a linked list in which each node points to its next node and to previous node So far we have discussed, okay, only a link field can point to its next node, and in circular linked list it can point to any node. But here in doubly linked list, just every single node will point to both the nodes, preceding node, succeeding node, and also the preceding node. How is it possible? Because in a doubly linked list, every node is having three parts. In doubly linked list, each node contains three parts. So what are these three parts? The first one is forward, FORW. The next one is info, and the last one is back. Contains these three parts. So we shall see how the node of a doubly linked list look like. See, this is the node of a doubly linked list. It contains three fields. This one is the back field, and this is the info field, and the next one is the forward field. See, look here. What are these three fields indicate? See here, back. Okay, first I will explain later. Back field. This is a pointer field which contains the address of previous node. Then forward is a pointer field or the link field which contains the address of next node. Then info, it contains its own actual data, its own data. it contains. So this type of linked list will be called as doubly linked list. So now we shall discuss back, info and forward. Back. It is a pointer field. It is a pointer field contains the address of the next node, the previous node. The previous node. Okay, back. It contains the address of previous node. Then forward, FORW. It is a pointer field. It is a pointer field contains the address of next node. Contains the address of next node. Okay, then finally info. It contains the actual data. Okay, what the actual data means here? Actual data means it contains its own data. Okay, every node is containing its own data. The same way here, info field, it contains its own actual data. The data, that may be anything. Okay, like this. It contains any data. Okay, come we shall see how the doubly linked list looks like. Take from start or head. It may be start or maybe head. Start. Okay. Then starting point. Then this is doubly linked list. Okay. Doubly linked list. 1. Then 2. Then finally 3. Doubly linked list. Start. This will be connected here. Okay. Then this points to this node. Okay. And this points to its previous node. Okay. Then it points to its next node. Then this points to its previous node. And finally it will be like this. So this is the doubly linked list. Doubly linked list look like this. Okay, look here. This is pointing to its next node, and this node is pointing to its previous node. Okay, so this type of a linked list can be called as a doubly linked list. Hope you have understood regarding linked list and types of linked list. In our next class, we shall go into discuss the operations of linked list, just like creation, traversing, inserting, merging, or deleting, all these things, the operations we are going to discuss in our next class. Regarding this class, if you have any doubts, you can ask me personally. Thank you.